Well, my name is Imad Alashi. I work as a consultant in Redify. I've been Microsoft MVP for a couple of years, 4 years. And today we're going to talk about moving the enterprise to platform as a service model. But before we talk about the details of how to do that and the perks of that, let's talk about the status quo of the general enterprise. How currently, if an enterprise with its current on-premises infrastructure and IT, let's inspect how this looks like. In the typical organization, it consists of the private network, a domain controller to control the machines and the servers, an Active Directory to authenticate the users, Exchange server to have your mailboxes, SharePoint to hopefully SharePoint to deal with file sharing, Skype for Business, and network shared files. This is how the typical IT infrastructure for a typical organization. This was from the IT perspective, from applications architecture, because most of the time organizations don't rely on just a basic services like the IT services. We also tend to build applications that will help us achieve more in our organizations. So these are a combination of in-house built applications or maybe bought off the shelf. So we have IIS, of course, to host our web applications, desktop applications. We have Windows services, message queues for some advanced scenarios in some organizations. How many people use message queues in their organization? A couple, that's good. But not MSMQ, sorry. Scheduled tasks to run batch jobs, and of course SQL Server and a network shared files. And I repeated the network shared files here because some organizations use the network shared folders and shared files as means of integration. So one application writes to this folder and another application reads from it to consume some information. So this is how it would look like in the typical topography. Now, the first option for you to, or for an organization to migrate to the cloud and get all the benefits of the cloud infrastructure as a service is the infrastructure as a service model. With this model, if we compare it to the on-premises one, you get benefits. This is the on-premises stack. I'm sure that you have seen this picture before. In on-premises, you have to deal with everything from the physical server, from the physical box, buying it in advance, putting it in your data center, and catering for its electricity, its cooling, its everything that you have to do yourself. With infrastructure as a service, what happens is that all this physical part is abstracted for you, and you start from operating system and above. You deal with virtual machines. You don't have to think of any data center or physical boxes that you have to deal with. And then the nice thing is that you can provision as much as you want and then remove as many as you want. There are benefits of infrastructure as a service. The first thing is that it's elasticity compared to the on-premises one. Once you need a virtual machine, you instantly can create it. You can scale it. You can put it down as well. You have a lot of movement there. But with the virtual box on-premises, you are locked to that virtual box. And if you want more machines, you'll have to buy a whole new box again. The second thing is control. From operating system, you have a full-blown operating system that you can use with all of the features that it brings. And the best picture I've like imagined how it's going to be expressed is the cockpit of one of the aircrafts of NASA. I probably would have been looked cool if I knew the name of the aircraft, but I don't know, so I'm not going to pretend. So with this control, you can have a lot of things that you can do. You can create Windows services. You can throw web applications. You can throw desktop applications, console applications, use the registry, use the services, everything you have in virtual machines. But with this, there are drawbacks. First of all, responsibility. Imagine that all these knobs of the aircraft, the things that you have to deal to patch your server, making it secure, making sure that the right ports are open, the right ports are closed, the updates of the operating system, some application you have thrown that overwrites the service of another application. There's a lot of responsibility that will be taken if you're dealing with operating system and up. Another problem is knowledge, because you need people who are really comfortable in running operating system and virtual machines. And you have to know exactly, not only the knowledge of the individual as a technology, but also you have to know what you have deployed before in this virtual machine. It's very easy to miss your architecture. It's very easy to miss your system. You have 6 virtual machines or 7 virtual machines, and you ask one of your developers, where did we install that application, how it's running? I only see it in the port. They're like, I don't know, we have to ask X, or I can't remember, let me check IIS. And there's a lot of this knowledge not properly documented and in the heads of the people. So one of the drawbacks. Mistakes. With all of these knobs, it's very easy to miss yourself and shoot yourself in the foot. Maybe unpatched server or a port that was open that people can get through. Also the tools. Now, if you have a virtual machine, virtual machine, and you want to automate deployments on it or automate the lifespan of the products on this virtual machine, there are some tools, but there are not too many, and these tools needs a lot of knowledge of themselves, and they can be so complex to run the virtual machine the way you like. Last thing is the total ownership cost. You have a lot of time and resources you have to spend on maintaining this operating system and these virtual machines. So if this is still an option, right? Not everybody is going to embrace new technologies and platform as a service. Sometimes you have some drawbacks, and you have to move these virtual machines to the cloud if you want to leverage some parts of the infrastructure as a service. So the typical topography of such a scenario is that you will have your on-premises servers just as is, and then you have, for example, express route to connect between your on-premises and Azure. But here you'll find that you are stuck also to virtual machines. You just move virtual machines from here to there and configure some of the IP addresses to make sure that everything is matching fine. Now, platform as a service. Let's consider what platform as a service brings. Like we said, the infrastructure as a service, it abstracts from the physical and above until the virtualization from the operating system. It's your own. With platform as a service, the operating system, the middleware, and the runtime is abstracted for you. So you don't have to deal with the operating system updates. You don't have to deal with the operating system security. You don't have to deal with the operating system maintenance. So if you also want to run a web application also, the middleware that gives you this capability as an IIS, this is also abstracted for you. You don't have to do a lot of knowledge on that middleware. It's there running for you. And also the runtime. So the thing that making it alive, making it scalable, making it you can interact with it. All of this is abstracted for you. So the only thing you have to do as an organization is to have your logic, your application, your system, your data, and put it on this platform as a service and use it then. Now, this is one of the highlights of this talk. People like 3 or 4 years ago when Azure was at the beginnings, when you used to say platform as a service, what used to come to your mind? Anyone? Web app, yeah. There was the web app, and there was cloud services, which is a web role and a worker role. And this is like, oh, this is platform as a service. It's going to abstract things for you. But since then, Microsoft has added a lot of services that are logically and are architecturally different from each other that you can put together like a Lego. So with Lego, you can have a block with wheels, block with with wings, put these together, bring them together, you can make an airplane, you can make a car, and this is exactly like it. I'm going to just enumerate some of these services to bring your attention that these services, from technical perspective, are there, and you can compose intelligent systems with such services. Active Directory, it's a way to authenticate your users. It's as robust as you can think of. Web applications to host your web applications. Logic apps, anyone heard of Zapier? All right, Logic apps is a way to connect different endpoints or different systems through HTTP without the ceremony that you have to do the writing yourself. So for example, SAP and Facebook, you want to connect the two together. There are connectors in the Logic apps that you can say, whenever an event happens on SAP, I want to post Facebook and say, well, we got a new sale, for example. You have these connectors already there for you, and you can utilize these Logic apps. Mobile apps, if you want to write an application that is installed on mobile applications and you want to do mass notifications rather than SMSs, it's there for you. Web jobs, scheduled tasks that run regularly or maybe continuously. Functions. The difference between functions and web jobs is that function is still also something that can be executed through invoking an endpoint. But the most beautiful thing about the functions is that you only pay for the time that this function was running. For web jobs, it's something that comes with a web application that you know that it's running all the time. But, and from historically perspective, like web jobs were long before functions. But functions now, they are there. They are like competitors to Lambda AWS, if you have heard of it. Media services to deliver media. Traffic manager to do load balancing over DNS. Redis is one of the nicest things that also Microsoft provides, which is key value store in memory that is distributed. You can use this for caching purposes. DocumentDB, anyone NoSQL? All right, beautiful. This is where you can store JSON documents of different structures that you are not bound to one specific structure. Think of MongoDB, if you know. SQL database, service bus, if you want to do advanced orchestration between independent systems through messages. You have also the little sibling of the service bus, which is queues. It's a very simple queue that can take a lot of messages at once and then make a background processor that consumes these messages and do some actions. Blob to store files through a REST API. Images, zip files, backups, or whatever, text files, you can store these in the blob storage. And last thing is the service fabric. Have anyone heard of microservices? Beautiful. Well, service fabric, even though I should say this very carefully, it's magic. But I know that from experience that from like dealing with the Microsoft infrastructure, or sorry, like services and products, the word magic is not really nice anymore, because for us it's just like the drag and drop button, right? And we don't really understand what's happening behind the scenes. Service fabric is nice. All of these, or many of these services, actually run on service fabric. You can run distributed processes on different machines, or maybe in a single machine as you like, on Windows boxes, on Linux boxes. You can achieve microservices architecture very easily with service fabric. So there's a lot of benefits of platform as a service. First of all, the tools. All of these services, they come with the right tools and the REST APIs that will allow you to deal with them very beautifully. One of the things that I want to highlight is the Azure Resources Management. Have anyone attended the session for ARM before? Yeah. The Azure Resources Management, you can declaratively declare topography that you want for your system, web application that writes to a queue with Azure function, and whether you compose how the system should look like and how many instances and how many sizes, and you can give it to our PowerShell engine and say, I want this topography, deploy it now to Azure. Wait a couple of minutes, and your resource group and your services are there for you. Another tool is specifically for web applications. You can, which is called, it's an open source project as well on GitHub. You can access the app settings. You can update the app settings. You can deploy from a code repository like GitHub or VSTS continuously. Someone checks in, it deploys. Checking the logs as they are happening. When the application is writing to the log, you can see the logs happening, log stream. So there's a lot of tools like these for these services. Another thing is that platform as a service brings the DevOps or encouraging the DevOps movement into the organization. Why? Because you don't need a guru who understands everything. And not only that, there's a lot of responsibility on the admin, and it's true. The admin, when he really resists any change, or he does not have capacity to comply to all the developers' needs to change some services, he has the right, because there's a lot of responsibility in this virtual machine that has everything with the responsibility. But with platform as a service, because you are only dealing with these services that are managed independently, that do not really corrupt other services in the system, you can encourage developers to take ownership of these services. Of course, maybe you can do this collaboration. The admins will not just go away, of course, but it's going to be a collaboration and encourage the DevOps movement in the organization. Agility. I can instantly find a template for Azure Resources Management that complies with or delivers a specific purpose, like the ones I said, web application and a queue and function. And then I can instantly deploy it and have everything provisioned. If I have a concept that is not in Azure template and I have it for me, I can create the right services instantly from the portal. I want a database, I want a web application, I want a queue, I want a function, and I can put them together nicely. And even I can export that. Security, because these services are limited and you are only exposed to what abstraction they are giving, there's more difficulty for mistakes and security vulnerabilities. Visibility, like we said, in the virtual machines, you don't know really what's running on unless you have a proper documentation. With platform as a service, you can see the independent services that you know that you have a web application here. You know that you have a database here. It's very visible and explicit. Scalability, also for platform as a service, it's much easier for you to scale. It's just, it's a matter of using a knob. And the last thing is the total ownership or the total cost of the ownership. There's a lot of less mistakes and maintenance that is compared to infrastructure as a service. This comes with drawbacks, of course. There are limitations, and one of the first limitations is calling GDI plus or user 32 in the process of the web application. Because these web applications are run as sandboxes, you don't have a lot of the functionality, one of which is GDI. Also, Windows authentication. For web applications, you cannot have Windows authentications to authenticate the end user. So how many have web applications in their organization where they depend on Windows authentication? Fair bits of hands, yeah. So there's no Windows authentications in platform as a service, but there are workarounds. Shared folders, and the shared folders, I'm talking about having a network shared folder that you put that your application is using for integration purposes. Because your web application will be sandboxed, it's also sandboxed from the file system perspective. And there are also means to how to change this. There are also some other stuff like how the processes are hosted in the web application and what they can access. Also, some of the things that will be limited is accessing to the registry. You cannot access the registry from the web application. The event logs, you can't have access to the event trace view per se, but you can see if you use that trace.listener and .write, you still have the logs, but in a file system, you can put them or in a blob. And there are SQL limitations, like linked servers or cross-database queries. We'll try to tackle some of this and see how we can bypass them. Before we do that, we have to brush briefly on how to connect your on-premises to the Azure, because at some point you will have to have a hybrid connection, or not that, but like a hybrid setup. One of the things that one of the ways that you can connect your on-premises to Azure is using the hybrid connection. This is, I just put it on the slide because it's one of the ways, but it's not advice because it's not meant for production or big deployments. This is where it gets real, site-to-site VPN. This is where you can really depend on having connections. Having said that, it's a little bit limited because you are limited to 100 megabit per second. The next option is Express Route, which is this is the star of the connection between on-premises and Azure. You have a dedicated line that does not go through the internet, and you can have speeds for the gigs. Now, preparing for the migration, and this is where it gets interesting. Before moving to platform as a service, the first thing you do is you have to build your catalog. You have to understand what you have in your hands. You cannot move what you don't know. And I've been into organizations to help them to move to Azure, and when I used to ask questions, nobody knew. They're like, this application, no one knows what it depends on what server it's deployed, and this is a disaster. So the first thing you do is to build the catalog, and the catalog can be as simple as an Excel sheet. You don't really need sophisticated tools to do it, but the most important is the knowledge that you have to have. So what to collect? First of all, the owner. I know the owner is a human and should not be part of the system information that you need to collect, but you have to grab the one who knows best about that application or that system. Otherwise, most of the organizations, they don't have proper documentation, so find the owner and get the information from him. Components. So if your system is consisting of Windows services and a web application, if you don't want to consider the Windows service as an application by itself, you can consider it as the components. Databases, integration points, how these applications are talking to each other through HTTP or other means. Dependencies, for example, does this application use the Active Directory to authenticate users? Or does it rely on the Exchange server to have some interaction with the mailboxes? The servers themselves, the names, the virtual machines, you have to know them. The technology stack of the application, the usage and performance metrics. This is very important because at some point you will have a hybrid setup. You need to know how much data is being transferred between the servers. And this will influence the cost, for example, and the architecture. Because, for example, in the Express Route, Microsoft only charges for the egress, not the ingress. So you have to really understand how this is set up. Finally, the business value. Because some applications you don't really care about. It was in the system for historical reasons. No one really cares about. If it goes down for 3, 4, 5 days, no one cares about. So knowing how much important the application for you will help you decide on how to move forward. This is a real diagram we have drawn for one of the clients to discover what they have. And it can as complex as this. You might have this right now, but you don't know. So how to decide between infrastructure as a service, platform as a service, or software as a service? This is one of the simplest diagrams that you can use. If it's a business differentiator, absolutely don't go to software as a service, right? If it's something that you distinguish yourself as an organization, this is a niche. If it's a low maintenance, then also you don't have to really to move it to software as a service. But if it's a lot of maintenance and it's taking from your time, and it's not a business differentiator, and there is a SaaS offering, there are some services that do this for you, then go move to software as a service. One of the best examples of this is email services. So sometimes some organizations will have a mail server that is used to send emails based on specific events. There are third-party services out there that will do this for you in much, much better way, in much scalable way. So this is where you move to software as a service. Otherwise, you move to platform as a service or infrastructure as a service. Between the two, how can I decide? Well, business value, like we said, if something is something that you want to invest in, because moving to platform as a service will incur change. You will have to change some of the code. You have to change some of the infrastructure. So you have to merge applications or kill applications. So if you are willing to invest in some parts of the system, then you can move to platform as a service. If you don't really need to invest a lot in that application or that part of the system, probably you don't want to move to platform as a service. Internal versus external. If you are using, for example, Windows authentication, it's going to be different from an external application that does not use Windows authentication, and it's going to be much easier for you to move to platform as a service. Frequency of change, if it changes a lot, probably you want to utilize the platform as a service features, which is automatic deployments and agility. Otherwise, you can just put it on a virtual machine on the corner. Elasticity requirements, specialization is if it's not part of your organization's niche or knowledge. Complexity, if you have part of the application or part of the system, an application that is really complex, and you know that the effort's going to be so big to move to platform as a service, then you might be forced to move to infrastructure as a service, even for temporary reasons. And lastly, competitive differentiation. We talked about this. So this is the diagram I have. Like if you know that for a certain application that there will be a lot of value to moving to platform as a service and little bit of cost to change to platform as a service, then you move to platform as a service. If the effort to move it to platform as a service is a lot, but you don't have the value of the platform as a service. You don't need the agility. You don't need the features. Then probably it's all right to stay on infrastructure as a service. So where to start? This diagram is one of the Microsoft books that is out there. It's free. The reference is at the last slide. This is exactly like the previous diagram, but it tells you where to start the migration. To be frank, I feel like this is too naive, because your applications or your system is not really this joint. It's like this. You have integration points and you have dependencies on other applications. So the way I found the best way to move your application is to find the leaf nodes in your dependencies. Find applications that have the least dependency upon, and from there move. Once you remove the leaf nodes and put them in a platform as a service with abstraction with the other applications, then once you reach the center, you'll find that most of your system is already platform as a service. You have to know that it's a process of incremental change. It's not a waterfall model. You don't just have a plan for what you're going to do for 3 months and you take one action to remove everything, to move everything, because things will change and you will discover things in your system that will influence your decisions. You have to know also that at some point you will have to run in hybrid mode. You will have something on premises, and you have something on platform as a service, or sometimes between infrastructure as a service and platform as a service. This is something that even you can have it for all the life of the system, or maybe you can use it as a temporary measures until you move everything to platform as a service. So conquering the platform as a service limitations, at least most of the important ones. Windows authentication. So Windows authentication, the typical way that these systems are built is that you have a machine, a user that is on the Active Directory. The web application is part of the domain controller. The IIS server knows Kerberos, and it knows the Windows authentication. The user is already authenticated once he accessed the web application. So once we want to move to platform as a service, because the web application does not support Windows authentication, we can utilize the Azure Active Directory. In Azure, the Azure Active Directory is a robust way to authenticate your users. What you can do is you can connect your on-premises Active Directory with the Azure Active Directory, either direct synchronization, or you can use ADFS to connect the two. The beauty of connecting with ADFS through a proxy is that once a user tries to access the web application, there is a small module that you can add through the portal by a simple configuration that will sit in front of your web application. All the requests that is coming to your web application will be filtered by this module and will block the traffic. So if it's coming in, it will check, is this user authenticated? No, then check with Azure Active Directory. Azure Active Directory knows that it's connected to ADFS. It will check with ADFS. ADFS will check with Azure Active Directory. Yes, this user is authenticated. Then it goes back all the way, and then the user will be able to log in. If there is in the local area network in your setup, if you have a proxy to put the service ADFS, this can happen seamlessly. So there's no sign-on page for the web application. And this is how you set up. It's very, very easy. You just go to, in the web application, you go to the authentication, you choose the app service authentication, click it on, Azure Active Directory, you have an application through the express route, and okay, suddenly you have a web application. The only thing that you have to bear in mind that your applications need a small change, which is you don't depend on the normal way of getting the user identity by the thread principle or whatever. You have to use the claims principle, but it's not a huge change. What about the file system? If you have two applications that rely on each other through the shared folder, there's two ways. It's either move to the Azure blob or the Azure files. The Azure blob you can only access it through REST API. But it's more agile. It's for scenarios where you don't really need to mount a drive on the virtual machine or whatever. Azure files gives you the ability to use the SMB protocol. So if you don't really want to move the web application or the dependency, you don't want to change a lot of it, and you want to still rely on the file system APIs, you can use the Azure files that will eventually write to Azure. And there's also REST API that access these files through the Azure files. This is also something that will help you decide if the files in the folder of the folder that is being used by the web application, if it's a read-only, then you ask yourself, does it change often? If it changes often, then probably you want to use a blob, because through the REST API you can change the files continuously, and it's going to be used by all the other applications. If it's not changing often, and it's like think of it as an email template that you use for the web application to send emails. You can duplicate, right? It's not a huge issue. The problem is that I'm not advising for this, but I'm saying that at some point you have to be pragmatic and just duplicate some of the files. Otherwise, if it's not read-only, of course, you have to use blob storage. One of the good things to do is also to abstract the way that you are accessing the external services, which is if you think the file system as an external service, you can abstract it away. This is a screenshot from a library that abstracts this away. It's a library that through interfaces you can hide the file system usage and hide the blob storage. So when you write through the interfaces and with your configuration, you can change the application to depend on these interfaces. And once you are ready to move to platform as a service, you make a switch and you instantly start writing to the blob storage rather than to the file system. Abstraction is your friend. Generating images and PDFs. There are 3 or 4 options. First, don't depend on GDI plus libraries to generate PDFs. Either use OpenXML, and there are more increasing libraries out there that use OpenXML to generate PDFs and images. Or use a third party, because there are third party services out there that you can use to generate PDFs through HTML generation. Or you can, for that part, you can utilize the infrastructure as a service. You can have a virtual machine at which you can run a specific service to generate these PDFs. And last, it's an option here, you can also use SQL Server reporting services. For SQL jobs and scheduled tasks, your options is web jobs and functions. And they are becoming more achievable and easy. Like, for example, the web jobs, you can use the cron standards to define how often your web job would run. And this file, you just put it with the installation, with the setup of your web job in the web app, and instantly you have a web job that is running for you. On-premises resources and private network, because all of these services you have to run on the public internet. You can, of course, provide or prevent access to it through authentication and authorization, but they are accessible from the internet. But what if you want to have something that is private in a private network? Microsoft brings Azure Service Environments. Azure Service Environment is just like the multi-tenant Azure web app setup, but it's scaled on a smaller level. Of course, relatively smaller, because multi-tenant is serving millions of customers. The multi-tenant is only for you. Sorry, the single tenant is only for you. The setup, it looks like this. This is a load balancer that is internal. I'm going to show you how you're going to connect it. There's a front-end servers that you have to have in your pools, and you have worker roles or worker pools that will serve your web application. So if you have on-premises resources and you want to connect them, you can connect them through the express route or the site-to-site VPN, and you will have these applications will have private addresses that will talk through the private network. These applications are not accessible from the internet. The internet does not know about these applications. Sticky sessions. Now, if you want to have a scalable web application, you use ARR at the front of your web application, and your load balancing will start distribute these requests to the different web applications. But if you are using sessions and your requests are bound to the machines that they are on, because they are using the in-memory, so every request that comes that has a previous request with a session, it will be redirected to the same server. Even if this server is loaded with memory, and these servers are not really loaded. So the way to overcome this is using distributed cache with Redis. You can have your session through a small configuration with the ASP.NET. You can say the session provider should have these memory providers in the distributed cache in Redis rather than having it in the machine itself. For the last thing is, if you want to really achieve platform as a service, you have to think of your model. It's not microservices, but you have to think of separating your applications to services that are talking to each other independently without relying on the architecture itself, without relying on the topology. You can see here that we have dismissed the express route because we don't really need to use the private networking, because we moved the dependencies from technical dependencies to HTTP. All of these services are talking through HTTP. Governance. If your organization have enterprise enrollment agreement, this is the hierarchy that you can use to govern your resources. I'm going to start from the bottom. The subscription is the unit at which you provision your services, your web applications and your queues. They start from here. You can provision them here. These subscriptions are governed by something called an account. An account admin can create subscriptions. You can create a subscription for a testing team. You can create a subscription for the production resources. This will give absolute isolation between the environments. The department can have different accounts, and eventually the enterprise will be the responsible of managing these accounts. So as on our organization, you have a very granular control over your services. Also, between the subscription itself, the Azure portal can provide for you a role-based access control for the services. So even in the single subscription, you have different developers with different responsibilities. A developer cannot, for example, manage that queue. It's not the responsibility of that developer. He can only read from, but he cannot change configurations. You can be an owner who writes and change. You can be a reader who reads only, or you can be well, actually not have access at all. Utilizing resource groups, you can accumulate all your resources into a single resource group, and then you can deal with these services as a single unit. For example, you need a testing environment for a new client that come to you, and you don't want to use the same services for the testing for a client X. So you can, from that resource group, you can create a template and provision another services, resource groups that have these typical services for you. Utilization of tags, and this is really important. It might be simple, but it's really important because you can tag your services with key value strings. So you can say, for example, a certain web application, department, HR. Another web application, department, accounting. Or you can put any key value that you can use departments, owners, testing or purposes for testing, for production. And then through the portal, you can easily see all the services that are fulfilling these tags. And the nice thing is that you can also do this through the billing. You can, using the tags, you can know the resources, how much they are costing you from aggregating with the tags. All right, that was a lot of talk. What about lock-in? Aren't we going to be locked in if we're going to use platform as a service? Well, you are already locked in. If you use any language, now you are locked into the language. If you use operating system, you are already logged into the operating system. The good thing is part of the lock-in is that you are utilizing the features of that language. When you are writing to Java or you are Node.js, you are absolutely embracing that stack, and you are utilizing all the features of that technology. But if you are not going to do this lock-in and do some abstractions, you can, but it will limit you from utilizing all these features from that technology. If your purpose is to be as independent as possible from the service providers, you can do abstraction, but this comes with a cost that you're not going to use their features. Rely on HTTP. This is one of the nice things, is that you shouldn't rely on technologies as themselves. HTTP is the new protocol that will help things. Now, if you use other protocols, connection protocols like MQP, there is service bus that will help you to do that. But the idea is don't depend directly on the file system or the existing of a file or on the file system. I don't know if we still have time for a demo, but maybe I can show you something that is fast. This is my machine. All right, so this is an application just to demonstrate to you that putting things together from these services, you can get really sophisticated systems. So this system, you can create ads. The topography is that this application will have a form that you can put some information about an ad with an image. Title, price, 30, description, whatever, and browse. I'm going to put me in the 70s. Category real estate, and then I'm gonna create. Now, what happens behind the scenes is that this record will write, will get the image, will upload it to the blob storage, and then will send a message to the queue to say that there is an image in the blob storage that needs to be changed to have a thumbnail, and then the queue will, or the web job will read the queue, will read the message, download the blob storage, transform it to a thumbnail, and upload it to the blob storage again. So if we open it here, I want to go to the web jobs. Start. Maybe before we go start, so I see Resource Explorer, Azure, Storage Explorer, and see. I'll be lucky if the web job is not started because we can show the queue message. Dismiss. Queues. Submit request. All right. It's already done. So if I go to, it's running, I'm going to stop it. Yes. Go back and create another one. Test 30, test, browse, put another one. Category, create. Here you see, this is from the previous request. It was pulled and the thumbnail was generated. So if we go back to the queue, I hope it's there. Now this is the queue that the message was written to. Think of this as MSMQ. Now if I start the web job, web jobs, refresh, start again, the web job will read from the queue, will pop it, and then will create that thumbnail for me. Here you go. It kicked in, and if I refresh this, it wasn't in the card. So if you go to real estate, back. If we go to controls ads, go to real estate, we will find that the record and the thumbnail is created for me. All right, so the last departing word that I need to highlight is that when you, as an organization, is trying to move to platform as a service, you have to realize that there's a lot of change that need to be done. And this change is not a bad thing, because this will give you the opportunity to utilize the features of platform as a service. The agility we talked about, the ownership that we talked about. Don't be afraid of making changes. So don't have the mentality that I want to move the applications as themselves to platform as a service as they are. But this is an opportunity for you to change things to be able to utilize the platform as a service, especially with things like continuous integration and continuous deployment. This is your opportunity as an organization to be agile and fast and deploy fast. So this is what I have for today. If you have any questions, otherwise, these are some of the links that you might utilize or benefit from. Continue your Ignite learning path. We have the labs that are really interesting. And if you have any feedback, or if you would like to get a ticket for flying drones, then this is your opportunity to rate this session. Sorry. Thank you so much.